Assalamu alaikum wa rahmatullahi wa barakatuhu. Okay guys, Chris has come back again. This is a continuation, I guess it's part 5 to the 3 days of darkness, and this star that's draining our sun, it seems, of its energy. And Allah subhanahu wa ta'ala knows best. I'll let the guy continue.
Object draining the sun of energy, a physicist's thoughts. In this paper, I'm going to show you that the object draining our sun of its energy is hiding in plain sight on SETI images, and also that it fits the profile of a brown dwarf star. Figure 1 below shows H12 SREM-A images provided by SETI from September 15, 2008 between 2:09 and 22:09. The images below show an object that seems to be parked in front of what has become known as the baffle. It's right in front of it.
Okay, the baffle is this. You see this thing protruding over here? That's a baffle. Now, that's at least NASA's official explanation as to what that particular object is. They're saying it's a baffle that they put in front of the camera. We certainly, at least the researchers on the ground, question that narrative with a lot of suspicion. Let's let the physicist explain what he thinks is going on.
We're going to look at it closer here in a second. The baffle still allows light detection over it, as most of the images show a dark or white circle in front of the baffle, or to the left of the object of interest. The sun is on the right side, but off frame for all the images. It's right here, and it's producing a CME on both sides. The black is the CME, the object of interest is the white thing. So it looks like the baffle was strategically placed on purpose. Good job. So look, we're going to look at figure 1 again. H12 SRE images provided by SETI from September 15th, 2008 at 2:09, 4:09, 6:09, 8:09, 12:09, 14:09, 16:09, 18:09, 20:09, and 22:09. An object to the right or in front of the baffle is seen, alternatively emitting black and white clouds of matter. Good job! Our detective work has paid off. The object of interest in these images is the object that appears to be made of a white ring, and that is ejecting clouds of matter in front and behind it. The clouds of matter appear to alternate between white and black. Most of the images shown in figure 1 and 2, most of the images shown in figure 1 are 2 hours apart. This means that this object is ejecting a huge amount of matter and material for its size. These matter ejections are like the CMEs, or coronal mass ejections, that our sun ejects on a regular basis. Only stars are able to sustain this kind of ejection, which suggests that this object is a small star. The size of the CME a star is able to produce is in proportion to its size, and since this star is so much smaller than our sun, it produces smaller and yet still dramatic CMEs. Now, there are 2 planets in front of the object, Earth and Jupiter. However, we need to realize that planets cannot go through the kind of CME production that we see happening here. This is reserved for stars only. Only stars are able to ionize their surfaces and atmospheres and accelerate large amounts of ions away from their surfaces. So the planets, Earth and Jupiter, in front of this object cannot possibly be responsible for the large amount of particles seen here being ejected from our object of interest. Figure 2 shows an expanded view of the object of interest and illustrates different details about the object. Figure 2, zoomed in image of the object of interest, right here. In figure 1, showing that the main object is the white disk in the middle. The black matter ejections are to the left and to the right of the object. Earth and Jupiter are also shown. Earth and Jupiter are about the size of the red and blue circles, respectively. Figure 3. Figure 3, H12 SREM A image on the left and H12A visible light image on the right from September 30th, 2008, showing that Jupiter has moved to the right, but Earth has stayed with the object of interest. Figure 3, above, shows the H12 SREM image on the left from September 30th, 2008. On the right of Figure 3 is an H12A visible light image from the same date. Both images show Earth and Jupiter. Jupiter has moved to the right since September 15th, but Earth has maintained a position close to the object of interest. Now, Jupiter moves more slowly since its orbital period is 12 years, and yet Earth, that moves much faster than Jupiter, seems to have stayed behind. This is an illusion produced by the motion of the SDO spacecraft on which the SETI imaging instruments and detectors are mounted. The spacecraft is in an orbit close to Earth's orbit and seems to have been designed to keep our object of interest in position close to the baffle. This suggests that the spacecraft was probably not mainly launched to observe the sun, but rather to observe our object of interest and the sun's reaction to it. The images in Figure 1 are detected by a SREM, Standard Radiation Environment Monitor Detector, which detects particles. Those detectors usually detect high-energy protons and electrons, but are also able to detect heavy ions. Heavy ions are heavy atoms that have been ionized by the fact that they have lost or gained electrons. Iron is one of those elements that have been ionized and would be called a heavy ion. Now, how can we determine which particles are being seen from which part of the images in Figure 1 and left image in Figure 3? Usually this information is provided by an imaging key, where certain colors or shades are assigned to certain particles of energy. This key is not available to us conveniently, so we are going to discover this by ourselves through examining some more images. Figure 4 below shows 2 images compiled from the SREM detector's detection of particles in a region of the inner solar system, close to the surface of the sun. We see 2 planets and what looks like a CME being ejected from the sun on both images. We know that the sun mainly ejects protons, and since both CMEs look mainly black, we may conclude that black is the color used to represent protons in all SREM images. Figure 4, 2 SREM images from September 11th and September 9th, 2016, showing the inner solar system. Coronal mass ejections coming from the sun can be perceived where the black color predominates. In Figure 1, all the way back here, right, our object of interest ejects black and white clouds alternatively. So we now know that the black clouds are probably protons being ejected. But what are the white clouds then? Well, we have already concluded that this object has to be a star because it is ejecting large amounts of matter in a sustained manner. Looking at similar images show that this object contains ejecting matter from the whole month of September in 2008. But if it is a star, it must be a small star, since the mass ejections are quite a bit smaller than our sun's. This would mean that this object is a dwarf star, ultimately a brown dwarf star. Figure 5, the 2 images show the same view of the inner solar system on September 11, 2016. The image on the left comes from a SREM detector, and the one on the right from a visible light imager. Now in Figure 5, we see the object of interest in the left image, and it is black on the sun facing side, but white on the side facing away from the sun. However, in the left image, in visible light from the same day, only an outline and a small and thin light blue line right in the middle of the object can be perceived. The rest of the object is in complete darkness to suggest that the object emits very little visible light and is therefore a brown dwarf star. However, we know that the left image in Figure 5 that this object is visible to the SREM detector and is therefore emitting particles. And since we know that the black represents photons, the black side facing the sun is probably emitting protons. Then the white side would be emitting other particles, and since this is a brown dwarf star and therefore mainly made up of iron, these particles are most likely to be heavy ions or iron ions. The protons that this object has gained must have come from the sun, and the little visible light that is now able to emit is most likely also due to the absorption of protons coming from the sun, which will allow the brown dwarf star to start a small amount of fusion reactions on his surface. Notice that there is a diagonal line across the top right corner of both images. This line is mainly white in the left SREM image, indicating that it is made up of iron ions. On the right visible light image, the same region is mainly dark, which means that these particles are not emitting light and are actually blocking the light from the background stars. This is evidence of the iron ion dust that has filled the solar system and has built up in our atmosphere, creating the red sky anomaly. This is illustrated in Figure 6 below. Figure 6, illustration indicating the object of interest with its dark outline and visible light, as well as a thin blue line in the center of the outline. The white diagonal region in the left image indicates that it is iron ions. This region is dark in the right image. Diagonal light of iron ions, object of interest. Only thin line and dark outline visible. No visible light emitted from same region. In Figure 3, which is repeated in Figure 7 below, the object of interest also looks dark in the right visible light image, but yet the strong mass ejection is clearly visible. I repeat, is clearly visible. Planet Earth is in front of the dark outline of the brown dwarf, but closer examination reveals that indeed the outline behind planet Earth is dark. In the image on the left, we see that at this time the ejection looks white, so the object is probably emitting iron ions, but the ejection is so strong that the iron ions are going to excited states and are emitting photons or visible light when they decay back to their ground state. In this way, the ejection becomes invisible. In this way, the ejection becomes visible in the visible light range. This is why white light in the right image can be clearly seen to be emanating from the ejection cloud. Whoa! To the left of our object of interest. This is illustrated in Figure 7. This is heavy, man. Wow. Iron ion cloud being ejected. Excited iron ions lead to visible light emission. Dark outline behind planet Earth. Figure 7 illustrated that is indicating the region on the left of the object of interest where iron ions ejecting or ejection is taking place. Figure 8 below illustrates that the SREM detection of the brown dwarf star reveals about its makeup. It emits both iron ions and protons. The protons it emits are probably protons that it has captured from the sun. In the 2008 images on the left, the object looks like it was surrounded by a dish-shaped iron ion cloud or envelope. In 2016, the brown dwarf has an iron ion cloud around it still, but this cloud has moved to the right side of the object, or the side facing away from the sun. The side facing the sun is mainly emitting protons. This is evidence to the fact that since 2008, this object has captured a lot of protons from the sun. It is due to this object's presence in the solar system that the sun has lost a lot of its primary fuel, i.e. protons, and is growing weaker and dimmer. Let me blow that up. Okay. Iron ion cloud or envelope, proton emission, iron ion emission. Thank you. It is very clear now. Iron ion emission. Gosh, you're smart. Figure 8, the brown dwarf has detected by a SREM detector in 2008 on the left and in 2011 on the right. In conclusion, the brown dwarf draining our star of its energy has probably been within the solar system since 2008.